Quelques images à présent du Chernobyl Day, une des 200 manifestations organisées aujourd'hui en Europe par un collectif.
Mémorable que celle de la catastrophe de
La région concernée est disposée d'honorer l'anniversaire de la catastrophe de Tchernobyl. 23
Sortir du nucléaire et sensibiliser le grand public au devoir de mémoire à la veille de la date anniversaire du drame de Tchernobyl. C'était l'objectif visé aujourd'hui.
For 300 years, the industrialized world has been burning fossil fuels. Coal, oil and gas are the buried remains of ecosystems laid down millions of years ago. Now they have been unearthed and are being put to work in everything from steam engines to jet aircraft. They power the lifestyles that many of us take for granted. The Earth's temperature is finely regulated by naturally occurring gases in the atmosphere. Their presence keeps the surface of the planet warm enough to sustain life. Burning fossil fuel produces gases, including carbon dioxide, which are enhancing this natural greenhouse effect. In the year 1000 AD, carbon dioxide was present in the atmosphere at about 270 parts per million. Around 1800, human combustion of fossil fuels began to leave an imprint on the atmosphere. Rapidly industrializing societies were suddenly releasing more carbon dioxide than the Earth's ecosystems could absorb. It took another 150 years for science to recognize the consequences. After decades of debate and denial, the picture is now clear. We, in the industrialized nations, are changing the climate. Every year, carbon building up in the air is trapping more heat close to the surface of the planet. On a large scale, this is influencing global weather patterns and ocean currents. No one knows what will happen next. The Greenland and Antarctic ice caps have begun to melt, putting coastal settlements under threat of catastrophic flooding. Weather patterns are less predictable, and extreme events such as hurricanes and cyclones are occurring more frequently and with increasing power. Whole ecosystems are on the move. We are threatened with mass extinction of species that can't keep up with their changing environment. Human society in agriculture is predominantly coastal. If the sea invades these heavily populated areas, hundreds of millions of climate refugees will be displaced. If we let this happen, there really will be no going back. There is still time to prevent this climate catastrophe, but we need to cut our greenhouse emissions to less than 20% of present levels. This means phasing out fossil fuels. The countries which are polluting the most need to make the biggest changes. And it needs to happen soon. Before we can cut back our carbon emissions, we need to know where the pollution is coming from. The biggest single source of greenhouse gas emissions comes from burning fossil fuels for electricity. Agriculture, transport and waste are also significant contributors. Some of the fuels we burn have higher greenhouse emissions than others. Coal is the most greenhouse intensive of all, even with improvements in efficiency. Gas is much more greenhouse efficient than coal, but it's still a non-renewable fossil fuel. Ideally, we would switch to renewable energy sources like wind and solar, which produce almost no carbon emissions. But these sources are said to be unreliable and too small scale to cope with our massive demand for energy. To make the situation even more difficult, the world is rapidly approaching the peak of oil and gas extraction, which is forcing prices up and making the search for alternatives much more urgent. For business as usual to continue, we need a large, centralized source of cheap, safe and reliable energy that produces no greenhouse gas emissions. This is the Copenhagen nuclear power station in France. Its 4 reactors generate enough electricity to power the entire southwest of Western Australia. Its carbon emissions when operating, 0. A 100 years ago, an obscure patents clerk in Switzerland realized that the atoms making up ordinary matter were themselves composed of enormous amounts of pure energy. Early 20th century machines were not capable of breaking atoms apart to release this energy, but it was only a matter of time before technology caught up with Einstein's theory. The key element, when refined to extreme purity, is a metal known as uranium. This is one of the few naturally occurring elements on Earth that is radioactive. That means it is unstable and prone to collapse, releasing some of its energy as radiation and tiny atomic fragments. As it does so, the uranium is transformed into a different radioactive element, which in turn decays over time through many transformations until eventually a stable form of lead is reached. If uranium is enriched to a high enough purity, these tiny disintegrations can be engineered to set off a chain reaction, with each decay setting off more atomic collisions. In the dark years of the Second World War, the major powers raced to turn these invisible atomic reactions into a weapon. In August 1945, the United States destroyed Hiroshima and Nagasaki with atomic bombs. The war was over, and the nuclear age had begun. The military reactors which produced the weapons-grade material also generated vast amounts of heat as a byproduct. By the late 1950s, these wartime models had been modified to drive steam turbines for electricity. First redesigned on a small scale for nuclear warships, these reactors were then scaled up, and the world's first commercial nuclear power stations went online. As other countries scrambled to develop their own nuclear weapons, the technology spread around the world. A new era of peaceful nuclear energy was heralded. From these beginnings, the commercial nuclear industry grew rapidly in a handful of countries until the 1980s. By 2005, 441 commercial nuclear reactors accounted for around 16% of world electricity generation and 6% of total commercial energy. Most of the remainder is generated by the carbon-intensive fossil fuels that are heating up the planet.